Hello guys, today we will see the Leetcode problem number 799, which is champagne tower. So let's read the question. What the question says. So we stack glasses in a pyramid where the first row has one glass and the second row has second glass and so on. Okay, and so on until the 100th row. Okay, each glass holds one cup of the champagne. Okay, then some champagne is poured into the first glass at the top. When the topmost glass is full, then exit into the glass immediate to the left and its right. So when the champagne gets full in this one of the glass, so it pour it into means it overflows into left and the right champagne. Okay, right glasses. When those glasses become full, any excess champagne will fall equally to the left and right glasses. Okay, so okay, and the bottom row has its excess champagne fall on the floor. Okay, for example, after one row. Okay, yes, this is the example which is given, you can read it. Okay, so let's discuss this problem. Okay, so if we have this cup. Okay, so and after that after filling it up fully, after filling it fully, so after that the excess champagne means the extra champagne will pour it into this and this equally. Okay, after that okay, so in this will be the first row. Okay, first row, then this will be the second, this will be the third. At the third row we have three cups. Okay, three glasses. Okay, the extra champagne from this will pour it into this and this. Okay, the extra from this will pour into this, pour it into this. Okay, so how we will approach this question now? Okay, so firstly we can say that, okay, so it is given that all the champagne means poured, we will insert into this uppermost glass. Okay, here only. Okay, so firstly we will take that here in this one, in this glass, the champagne which will be poured is just like as a 3. Okay, 3, or we can say as a 4. Okay, we can say it is as a 4. Okay, so 4 glass of champagne was poured into that first container. Okay, so topmost container, topmost glass. Okay, after that the champagne which will be exceed here, the champagne which will be exceed here, what will be the amount of that champagne? Okay, let's zoom it. Okay, what will be the amount of that champagne? Okay, I will first erase this one and this one. Okay, okay, now the champagne which will be inserted into this and this, what will be the amount of that? So the one glass of champagne will consumed by that glass only, so that's why the champagne which will be exceeded is will be now remaining as a 3. Okay, so the amount of champagne which will be consumed by this this glass will be 1. Okay, because it has a capacity of 1, so that's why it will be consumed and it will be converted into 3 now. And after that it is divided into 2 parts, means here. Okay, so the champagne which will go to this part will be 3/2 and this part will be 3/2. Okay, this part will be 3/2. Okay, so the 3/2 will go equally into each of the container. Okay, now this contains, okay, this contains 3/2. Okay, and this also contains 3/2. After this, how much amount of the champagne will contain by this and how much amount of the champagne will contain by this? This will go into this will go into this. Okay, so how much amount they will be distribute? Okay, so the amount they will distribute is the amount which will be distributed is when this champagne is full. Okay, when then only it will pour it into it's next one. Okay, if this champagne is full now, okay, firstly this champagne is full, so we have 3 by 2 equal to, okay, so the 3 by 2 equal to 1.5, okay, 1.5, and this will be also 1.5. okay, we can write it as a 1.5. okay, so the 1.5 is there. Now if this champagne is full only, then only we will insert this into this. Okay, otherwise this remains 0, means empty. Okay, otherwise this remains 0. Or if this champagne 1.5, if it is greater than 1, greater than or equal to 1, sorry, if it is greater than 1, okay, we can say if it is greater than 1, then only it will pour it into this. Okay, so how we will pour this? Okay, so the 1.5 we have now, but one cup of the champagne, one glass of the champagne will be consumed by this only. So that's why now we have 0.5% of the champagne. Okay, 0.5%. okay, now the 0.5 champagne we have, and we will pour this champagne equally 0.5 divided by 2 into this. Okay, so this consumes 0.5 divided by 2, and this also contains 0.5 divided by 2. Okay, 0.5 divided by 2, okay, into this. Okay, after this 0.5 divided by 2, so again this will contain 1 by 5. Okay, and 1 by 5 will be equally distributed into this 0.5 divided by 2 and 0.5 divided by 2. Okay, and then now here this 0.5 divided by 2 and this 0.5 divided by 2 means it contains 0.5 divided by 2 plus 0.5 divided by 2, and this results into 0.5, and this results into 0.25, this results into 0.25. okay, we have divided 0.5 divided by 2 and we get 0.25, and by dividing 0.5 divided by 2, okay, we get the 0.25. okay, it's a 25. okay, it's a 25. Sorry, okay, 0.5. okay, and this is also a 0.5. okay, 0.5. okay, so in this way this will be distributed. Now let's condition them. Okay, how our conditions will be. Okay, how our conditions will be. Okay, how our okay, so by this explanation you can go up to the that intuition that we will have to apply the dynamic programming concept here. Okay, so now we have, okay, now initially our DP of 0th. Okay, so firstly we will make the 2D DP array. Okay, which will contain the DP of DP, means vector of vector. Okay, vector of vector we will contain. Okay, vector of vector, which will storing the data in double format. Okay, so we can initialize it. Okay, then after this how our conditions will be. Okay, how our conditions will be: firstly the DP of 0th, DP of 0th will poured with the 4. Okay, means initialized it with the how much of the drink we have to pour. Okay, then for this and this, okay, the for leftmost and the rightmost that glass, we have the special conditions. Means for these glasses we have only the left one, and for this we have only the right one. Okay, and if after that, if we have for fourth one, if we have this glass, and this glass. Okay, so the water which will be poured here is from only this glass, okay, and from this only the water will come to this glass, okay. So for the leftmost and the rightmost we have only one overflowed, okay, and for all of them the from 1th index to n minus of 1th index we have that this also be poured into this, the overflow from this, the overflow from this also be poured into this, from this and from this. So this all internal indexes will have two source, okay, but the last and the first index will have only one source, okay. So that's why we will divide them and write the conditions for them, okay. So the condition which will be is for dp of zeroth of sorry not for zeroth, ith index, for the ith index and for zeroth index, okay. So for all of them firstly we will check, okay, from the source. If we are importing the drink from the source, so we have to first check that if that drink if that source is full or not, okay. If that source is not full until now, so it will not explode or it will not overflow. Until then if it is overflow, then only we will apply these conditions, okay. Means for every node of them, okay, for every overflow we have to check firstly that dp of I minus of 1 I minus of j, means for every conditions where we are initializing it, so we have to check if their source is greater than 1 or not, okay, greater than or equal to 1 or not, okay. So firstly now we will make the conditions that dp of I and j. So for this one, for this condition dp of I or j, sorry not for the j, for the zeroth condition we have dp of I minus of 1th and zeroth, okay, because this index, okay, firstly we will talk with the indexes, okay, now, okay. So this is the zeroth bit index 1 2 0 1 0, okay. So now for this you can see here that we have this drink, if it is overflowed then it will come into this, okay, and after that here, okay. So that's why we have initialized it with zeros only, okay. Then when dp of, okay, when dp of for the last index dp of I and the jth which we are talking about j minus of 1th, or we can say that if this is the second index, so our last index will be the 1th, okay. So we can already we can also say that this can be I minus of 1th, okay. I minus of 1th is equal to dp of I minus of 1th and this will be the I minus of 2th, okay, because the 1th index now, okay, now we are at the ith is at 2, okay, and I minus of 2 will be 0th, okay. In this way we can do this, okay. So this will be the one of the condition, and after that again we have another conditions for the internal nodes, okay, for this and for this, because we have two sources here now, okay. So for this we will firstly take the condition that if their sources, means this and this, all are greater than 1 or not, Okay, if they are greater than 1, then only we will apply this condition. So I am not writing here the if condition. We will see it in a code. Okay, so when we have ith and jth, okay, jth will be start from 1th to n minus of 1th, means if it is 4, so n minus of 2th will be this will be the n minus of 1th. Okay, so n means this will be the n. Okay, 4 currently, so I am writing it n only. Okay, then I on jth means jth will be start from 1th to n minus of 2th. Okay, so and for this we have 1, and here the source is from 0 and from 1, and if we have this as a 2, so the source is from 1th and 2th. So you can simply understand that the source is from j minus of 1 and j minus of j. Okay, so dp of I and j plus equal to, we will write it plus equal to dp of I minus of 1 and jth minus of 1, and also the dp of, because there are two sources, dp of I and j plus equal to dp of I minus of 1th and jth. Okay, the j minus of 1 and j, these are the two sources. Okay, so these are the conditions for our dynamic programming problem. Let's see the code first now. Okay, the code is simple. The conditions which we are written now, so this all the conditions which we have to apply. Okay, now firstly we will initialize it with the query row plus 1. So for not having the index out of bound, so we will initialize it with the row plus 1, and dp of 0th dot resize, we are resizing it because our size of every row is changing now. So for 1th row we have one size, for 2th row we have two size, so that's why we are resizing it. Okay, and then after resizing it, so we have poured in the 0th based index. So here we are dealing with the 0th based indexing, and for 0th index we are pouring all the water which we have. Okay, then after then we start from the 1th index to the query row index. Okay, where we have to find out. Okay, then dp of I dot resize we are doing. Then resize, or the resize function what applies that the size of the array, it resizing the size of the array. Okay, then we have these two conditions which we have discussed it earlier, and this if conditions we have to apply everywhere, because if this is if conditions we do not apply, so our answer can go in negatives. So we don't want it in negatives. Okay, so that's why we are applying these conditions. If their sources are greater than 1, then only they overflow, otherwise they do not overflow. And we have only the 0, means empty glasses there. Okay, and if this okay, so this condition simplifies that 0 0 if we have. So for this first and last, okay, this will be the indicating the first one, the first initial, the first, and this indicate the last glass which are at the every row. Okay, so for first and last we are calculating it initially, and for all of them, all the remaining which are at the middle, okay, which are at the middle, because we are calculating them individually, because for the first and last only one source is there, only one source. Okay, for them only one source is there. Okay, but for the middle of them we have two sources. Okay, we have two sources. Okay, So that's why we are calculating the first and the last initially. After that we are calculating all the middle portions. Okay. And and after that, now after while calculating the answer, the final answer, so we will firstly check that if it is greater than 1 or not. Okay, because we are storing the amount of water which are present in that glass. Okay, so for first glass, for the initial first glass, we have, if we have 4, so we have 4. Okay, and if this is having the 4, so it is greater than 1. Okay, it is storing greater than 1. So that's why when any of the glass is storing greater than 1, means it the remaining water will be overflowed, but their value we are storing it as a greater than 1. Okay, so the in a real life scenario it will store only the 1th, but we are for calculating our answer, we are storing the 4 on the topmost of the glass. So for this we have to check if it is greater than 1, so we will return it 1, means it is fully filled. Okay, and if it is not greater than 1, so we will return the glass, that amount of the glass which is filled already. Okay, and this is the answer. And if you have any of the doubts, please comment down below, and I will see you in the next video. Thank you.